Hello students, we are solving the IB Math AA AGL past paper questions and currently we are solving the IB Math AA AGL May 2023 paper 1 times on 2 past paper. Today we will be solving the last question, that is the question number 12 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in my YouTube channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 12. The maximum mark is 70. The subpart A says, by using an appropriate substitution, show that integration of cos of root x with respect to x is equal to 2 times square root of x times sine of square root of x plus 2 times cos of square root of x plus c. It is containing 6 marks. Okay. And just by looking at this portion, by using an appropriate substitution, some students get confused. You have to, of course, you have to substitute, because how can you otherwise integrate cos of root x? You know the integral of cos of x, but you do not know how to integrate cos of root x. So you have to do the substitution. Okay. So what will you be substituting? Obviously, we'll be substituting root x because we do not know how to integrate cos of root x, but we know how to integrate cos of x. So if we take some other variable, maybe if it is t equal to root x, then it will be cos of t, and we know how to integrate cos of t. So that is what we will be substituting. Okay. So that is the natural thing that we will be doing. But as soon as you are reading this portion by using an appropriate substitution, don't think that you have to do something else. Just what you would have done otherwise. Okay. So it is part A. Let t equal to root x. Okay. So, and this can be written as x to the power of half, because in calculus you do not keep the radical sign. You cannot keep the radical sign. So I'm writing square root of x as x to the power of half. So dt over dx is equal to half times, half comes down, and x gets raised to the power of half minus 1. Okay. So this is half times x to the power of negative half. Or you can write this as 1 over 2 x to the power of half. Okay. So therefore, dx, because I have to substitute wherever we are having x. So I have to substitute for root x and I have to substitute for dx. Okay. So dx will be equal to 2 times x to the power of half dt. Because dt over dx is equal to 1 over 2 times x to the power of half. So dx will be equal to 2 times x to the power of half times dt. And what is x to the power of half? It is root x or equal to t. So this is equal to 2t dt. Okay. So therefore, integration of cos root x dx is equal to integration of cos t, and in place of dx I am writing 2t dt, and 2 is just a coefficient, so I am taking this outside the integration sign. Okay. And this is d and dt. And I can write this as, don't write cos t, because there is a high probability that you will be just multiplying these two t's and you will be writing it is the integral of cos of t square, which is incorrect. Okay. It is the integral of t times cos t. So I'm rewriting this part, 2 times integral of t times cos t dt with respect to t. Okay. And t is a function of course, t. And this is also another function containing t. So these two are multiplied together. Hence, we have to use a by parts rule. Okay. And what is the by parts rule? It is integration of u v dash dx I'm writing with respect to x, and this is given in your formula booklet as well. So integration of u times v dash with respect to x is equal to u times v minus the integral of u dash times v with respect to x. Okay? And which one is u and which one is v dash? In order to select the u, the first function, we will be using this ILATE. Okay? So over here we are having t and cos t. I stands for inverse trigonometric functions. You know this, but in case you are confused, you should not be, but let me write it. In case there is even a single student who doesn't know this and is watching this video, I'm writing these things for that student, okay? So E is the algebraic function, L is the logarithmic function, E is the algebraic function, T is the trigonometric function, and E is the exponential function, okay? So since E, over here we are having the algebraic function and the trigonometric function. Since E is above T, I'll be taking U as T, the first function as T, okay? So U is equal to T. Therefore, U dash is equal to 1. Derivative of T with respect to T, of course, is 1, okay? And what is V dash? V dash is cos T. So therefore, V will be equal to integral of cos T with respect to T, which is equal to sin T. I will not be writing the plus C over here, okay? So this should be equal to 2 times UV. U is T and V is sin T minus integral of U dash is 1 times V is sin T dt. Okay. So this is equal to 2 T sin T, and 1 times sin T is sin T. An integral of sin T with respect to T is negative cos T. And there is this negative sign in front, so it is negative of negative cos T. And you can write the constant of integration within the brackets and multiply that with 2 and write another constant of integration outside the bracket as the final answer. I am just writing the constant of integration outside, okay? Next, I have to substitute back the value of t, the expression for t, which is root x. So this is equal to, and let me see whether they have taken, okay, they have multiplied the 2 with each of the two terms. Okay, fine. So it is 2 times t is root x, sin t is sine of root x, and negative of negative is positive, so it is plus 2 times cos of root x plus c. See, this is the same expression that you are given, 2 times root x times sine of root x plus 2 times cos root x plus c. Okay, so we have got this expression. Okay, show that. So let me write shown. Okay. Now coming to the subpart B's question, the curve intersects the x-axis at x1, over here x2, x3, x4 and so on. Okay. The nth x-intercept of the curve xn is given by xn equal to 2n minus 1 whole square times pi square over 4, where n is a positive integer. Subpart B, write down a similar expression for xn plus 1. This is xn and we have to get a similar expression for xn plus 1. In place of n, I will be writing n plus 1. That is the only difference. So, n plus 1, xn plus 1, see, it is containing just a single mark, equal to 2, and there is n, so in place of n, I will be writing n plus 1 minus 1 whole square pi square over 4. Okay, so this is equal to 2n plus 2 minus 1 whole square pi square over 4, which is equal to 2n. 2 minus 1 is 1. So 2n plus 1 whole square pi square over 4. Okay. So this is the expression for xn plus 1. Okay. The regions bounded by the curve and the x-axis are denoted by R1, R2, R3 and so on as shown on the above diagram. This is the diagram. See, this is R1 extending from x1. This point is x1 and this point is x2. So the subscript of R is same as the previous subscript of x. It is ranging between x1 and x2. So the subscript of R for this region, that is 1, is same as the subscript of x of the left hand x-intercept. Okay. So from x2 to x3, it is R2. From x3 to x4, it is R3. Okay. So this way it is going. Subpart C's question is calculate the region area of region Rn. So it is just a general expression that they want to get, and it is having 7 marks. It is containing 7 marks. Give your answer in the form of k and pi, where k is a positive integer. Okay, so now you are seeing some of the regions are below the x-axis, some others are above the x-axis. When the n value is or the subscript is an odd number, then the area is below the x-axis. When the subscript is an even number, the area is above the x-axis. So for R1, say for R1, area of region R1, it will be below the x-axis, so it will be negative from x1 to x2, and the expression was this function expression. So cos root x dx. Okay. Not only for R1, for R3, for R5, we will be having a leading negative sign because these are below the x-axis. Whereas for area of R2 or R4 or R6, it will be, for R2, it will be from x2 to x3. Since it is above the x-axis, I will not be putting a leading minus sign. It will be cos root x dx. Okay. So now that they are saying find the area of the region Rn. We do not know whether it is below the x-axis or it is above the x-axis. This is needed because that will be telling us whether to put a leading negative sign or not before the integral sign. Okay, since we do not know, what we can do is area will always be a positive number. Area can never be a negative number. So it is better, and because we do not know which area is to be considered, therefore we will be writing area of Rn is equal to the absolute value, whatever value we will be getting after the definite integral. If it is negative, the absolute value will be changing it to the positive value, or else if it is a positive number, it will be staying as it is. Okay, so we can use this absolute value notation and we can write this as integration of x into xn plus 1 cos root x dx. Okay. And we know what is the integration of this. We have in fact shown that the integral of this is equal to this part, the right hand side. Okay. So we will be just copying this right now, and I will be writing it as q root x sine root x plus 2 cos root x plus c. In fact, the c will be getting cancelled because it is the definite integral. And in place of xn and xn plus 1, we have found the expressions for xn was given and n plus 1 was found. So I will be writing, in place of xn, I will be writing 2n minus 1 whole square pi square over 4. And this is 2n plus 1 whole square pi square over 4. This is 2n minus 1 and this is 2n plus 1. That is the only difference. Okay. And there is this absolute value, closing part. Okay. So this is this. And then we can just substitute the x values. Okay. So this is equal to, therefore, area of Rn is equal to, first of all, we will be substituting this. So it is 2 times root of 2n plus 1 whole square pi square over 4 times sine of root 2n plus 1 whole square pi square over 4 plus 2 times cos square root of 2n plus 1 whole square pi square over 4. And this is the first part, minus, I'm not writing the c anymore. It is 2 times square root of 2n minus 1 whole square pi square over 4 times sine of square root of 2n minus 1 whole square pi square over 4 and plus 2 times cos square root of 2n minus 1 whole square pi square over 4. Okay, fine. And there is this absolute value notation. Okay, so this is equal to, now if we are square rooting the thing, that means I am getting this as 2 times 2n plus 1 pi over 2 and sine 2n plus 1 and pi over 2. Okay, plus 2 cos 2n plus 1. I'm writing pi over 2 because this will be telling me that this is an odd multiple of pi over 2, because sine pi over 2 is equal to 1 and sine 3 pi over 2 is equal to negative 1. So it can either be positive 1 or it can be negative 1, but it will not be equal to 0, because if it is 2n pi over 2, that will be equal to n pi. So sine n pi will be equal to 0. That is why I have written this separately, just to show that it will be sine of odd multiple of pi over 2 is either equal to positive 1 or equal to negative 1. Okay. So this and pi over 2. Okay. And minus, I'm just opening the brackets. So this and 2n minus 1 pi over 2. So, okay. So these two will be getting cancelled and I'll be having sine 2n minus 1 pi over 2 minus 2 cos 2n minus 1 pi over 2. Okay. This is the absolute value. Okay. Now, when n is even, first of all, let me take when n is even, because n can be an even number, n can be an odd number. Okay. So when n is even, n is a positive integer. Okay. So n can be either a positive even number or n can be a positive odd number. So when n is even, this is 2n plus 1 pi. I'm keeping it as it is. So AR, area of Rn, is equal to 2n plus 1 pi is there, and n is even. So n can be 2, n can be 4. So when n equal to 2, 2 times 2 is 4, 4 plus 1 is 5. So sine of 5 pi over 2. What is that equal to? If I just draw this is 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2. This is 4 pi over 2. And finally, this is 5 pi over 2. We are coming to this part. So sine 5 pi over 2 will be equal to positive 1. Or when n equal to 4, say, 2 times 4 is 8, plus 1, 9. So this was 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and finally 9 pi over 2. Again, I am coming to this point. So sine of 9 pi over 2 is also equal to 1, positive 1. Okay. So I am taking this to be 1 plus 2. What is cos of an odd multiple of pi over 2? An odd multiple of pi over 2, cosine of an odd multiple of pi over 2 is always equal to 0. Cos pi over 2 is 0, cos 3 pi over 2 is 0, cos 5 pi over 2 is 0. So it is always equal to 0. Okay. So this is 0. And then again, I am coming to this part. So it is 2n minus 1 pi times. Now n is an even number. Let me take n equal to 2 first of all. 2 times 2 is 4. 4 minus 1 is 3. And sine 3 pi over 2 is negative 1. Similarly, if I take n as 4, 2 times 4 is 8, minus 1 is 7. 7 pi over 2, it was this way. This was 1 pi over 2, this was 2 pi over 2, this was 3 pi over 2, this was 4 pi over 2, this was 5 pi over 2, and this was 6 pi over 2, and finally this was 7 pi over 2. So again, we are seeing it is negative 1. When n equal to 2, it is sine 3 pi over 2, so it is negative 1. So every time we are seeing whenever n is an even number, sine of 2n minus 1, that is odd multiple, not odd multiple, 2n minus 1 times pi over 2 will be negative 1. Okay. So this is negative 1. And again, odd multiple of pi over 2. Cos of odd multiple of pi over 2. 0. So this is minus 2 times 0. Okay. So this one is, I can write this as equal to, this is 2. I'm just expanding 2 in pi. I'm just expanding this part. 2 in pi plus pi, and this is 0. And this one is, this is negative 1, and this is another negative sign, so it will be positive. So it is positive 2 in pi and minus pi. So this is equal to 4 in pi. Okay. Now, if it is when n is odd, sorry, area of Rn is equal to, I'm taking this expression, it is 2 times 2n plus 1, or else I'm starting with this. I'm starting with this expression, okay? 2n plus 1 pi. And now n is odd. So let us take this n value as 1. 2 times 1 is 2 plus 1 is 3. So sine 3 pi over 2 is negative 1. So this will be negative 1. You can take any value of n. Next value can be n equal to 3. 2 times 3 is 6 plus 1, 7 pi over 2. We have seen 7 pi over 2. It comes over here. So again, it will be negative 1. So this is negative 1. Okay. And this will be 0. 2n plus 1 in n is even or n is odd is not changing the value of cost of some odd multiple of pi over 2. It is always equal to 0. Okay. So this is plus 2 times 0. And then again, this will be 2n minus 1 pi. And this time, since n is odd, if I take n equal to 1, 2 times 1 is 2, 2 minus 1 is 1. Sine pi over 2 is positive 1. So I have to take, you can take other n values. 2 times 3 is 6, 6 minus 1 is 5, and 5 pi over 2 is this point. So again, sine 2n minus 1 times pi over 2 is equal to positive 1. Okay. And the last one is 0. 2 times 0. So this is equal to 2. There is this negative sign, so it is negative 2n pi and negative pi, and this portion is negative 2n pi and positive pi. These two cancel and it is equal to negative 4n pi, which is equal to, because there is this absolute value notation, so this is equal to 4n pi. So we are seeing the value of the area of R in whichever n value we are taking, whichever region we are taking, doesn't matter, but it is always equal to 4 n pi. Of course, the n value will be changing from one region to the other. Okay. So because if it is R1, the area will be 4 times 1 times pi, that is 4 pi. If it is R2, it will be 4 times 2 times pi, it will be 8 pi, and so on. So the expression is 4 n pi. N value will be changing according to which region we are selecting. Okay. Therefore, area of region Rn is always equal to 4n pi. Okay. So this is the final answer. Coming to subpart D, hence show that the areas of the regions, these are the regions bounded by the curve and the x-axis R1, R2, R3 and so on, form an arithmetic sequence. Okay, so subpart D, area of R1 is equal to 4 times 1 times pi is 4 pi. Area of R2 is equal to 4 times 2 times pi is equal to 8 pi. Area of R3 is equal to 4 times, this is 4, okay? 4 times 3 times pi, it is 12 pi, and so on, okay? So therefore, they are saying that these areas form an arithmetic sequence. So there should be a common difference between them. So therefore, since area of R2 minus area of R1 which is equal to 8 pi minus 4 pi equal to 4 pi is equal to 12 pi. I can write 12 pi minus 8 pi, which is area of R3 minus area of R2. Therefore, there exists common difference between them. Okay, common difference of 4 pi between them. Therefore, they form an arithmetic sequence. Okay, so this is the answer for the subpart D. Okay, so we have completed answering this paper completely. Thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math ASL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. In case you are interested in joining my sessions, please do contact me for more details. And in case you're liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my videos. And please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. We meet again very soon when we'll be starting with a new paper. So till then, bye.